So today we'll look at chemical reactions in quantities, but more again, just more or less just finishing off chemical reactions. And the chemical reactions that we have to finish off with will be combustion reactions. So things that burn. And this is sometimes the tricky part of this is the fact that combustion reactions are always going to react and happen with oxygen in the air. And when we do deal with oxygen in the air, we need to remember that we're talking about O2. Now, sometimes combustion reactions will talk about burned in air or completely oxidized. When we talk about those, we always are looking at the O2 aspect of that. So, because if something is going to burn, it needs to have O2 present. If it is going to burn in air, the only component of air that we're worried about in burning it is the O2. Now, when we look at kind of the general equation here, all organics or anything that is burning usually is organic in nature, and therefore it should have at least carbon and hydrogen. It may or may not have oxygen as a part of its molecular structure. The state that it's found can be as a gas, can be as a liquid, or it could also be as a solid. So that's where we have this ST first state. Burning in air, that's because, again, oxygen is the only thing that matters from there. Now, when this happens, there are only two products for this. There are only two products of all combustion reactions, and that is carbon dioxide and water. Now, if a combustion reaction is not complete, then other products would be given off, but we are only going to worry about complete combustion reactions, meaning only carbon dioxide and water are going to be given off as byproducts of combustion reactions. So when we look at these predicting the balancing and completing these reactions, I'll need to resize this because there are going to be some that we might need to write our tombstone for, but it might not be in there. So we have this predicting component. Well, again, because the only two products that we are going to see in a combustion reaction are going to be carbon dioxide gas, as it was normally going to be found, and water. Now we need to balance the chemical reaction. Well, these are dealing with some very large numbers. Now, usually, first time we see numbers like this, sometimes students get a little anxious about that, and the fact that we have 12 carbon and 22 hydrogen and 11 oxygen, that really sometimes upsets students because we are like, oh my gosh, I've never used numbers that big. That's okay. It's just going to work. And so we do it the same way as we always have and fill out what we have here. Now, sometimes some will want to add another oxygen because it's as another reactant, but we can't. And so when we look at these, we have 12 carbon, 22 hydrogen, 13 oxygen. 11 plus 2 is 13. And then I go on the other side and I see I have 1, 2, and then 3 oxygen. Nope, 3. It's already thinking about how to balance it as I'm writing it there. So now what we do is we go through the process just like we have. It's just that we now are going to have bigger numbers. Well, we can always check to see if we did it right by seeing if we can be reducing it. And we'll do that at the end. So I'll need at least 12 in front of the carbon dioxide because I need 12 of my carbon. Well, that changes things quite a bit in that I have my 12 times 2 is 24 plus 1. So I'd have 24 plus 1 to go 25 oxygen. But that's going to change even more because we have to put an 11 in front of water. Why do we have to put an 11 there? Well, I need 22 of them, and so we would have 11 times 2 is 22. Well, now we got to count up our oxygen again. I have 12 times 2 is 24 plus 11 to give me 35. So now we see this and we're like, okay, so that's really big. And so now it kind of gets a little bit tricky, is like, how do I do this? And well, we can set this up in a way. We can say 11 plus what times 2 equals 35. Now, where am I getting that from? The 11 from that is there, plus what number do I put in front of my oxygen here to equal 35, what I have over here. And so when I see that, I can go, oh, okay, I need to put a 12 there to equal because 35, because 11 plus 24 will equal 35. So I will put a 12 in front of my oxygen. And now I will have a balanced chemical reaction. So what really happens sometimes is that we want to solve for oxygen last in some of these. And that's going to make our lives just a little bit easier because it's by itself. It's the only one that's by itself. Kind of do what we need to do to balance out the carbon, just as we did, and then come back and balance out that oxygen. So now let's look at the next one over. And that, well, we probably could have kept that there. And so now we have ethanol. Well, burning ethanol. So let's see burning of ethanol. And so we have C, we have H, we have H, or hydrogen, and we have oxygen. Now we got to be careful when we count because we can see here our hydrogen are in two different places. We need to pay attention to that, just as we have been for our oxygen have been in two different places. I don't even have any products, so how am I supposed to know? Well, again, because it's a combustion reaction, carbon dioxide and water, should be gas, are given off all the time. And therefore, that's the only things that are present too. We can't have sulfurs or anything else added. You can, but those are more complex. Those are dealing with gases like gasoline and some of those types of things. And we're not worrying about that at this time. Those would be also byproducts because if it's a part of the reaction, it's a part of the product. And therefore, we're not dealing with those, so we're not going to worry about those. So I have 2 and 1, I have 6 and 2, and then I have 3 and 3. Well, you can see some things should be pretty nice. However, when I look into balancing my carbon, now all of a sudden my oxygen are unbalanced. But that's okay. We're going to save it for last. And so when we have that, it'll be a 2. My oxygen is 4 plus 1 is 5. My hydrogen looks to be pretty easy to balance out with the 3 to give 6. I then need to balance out this again, so I have 4 times 3, 4 plus 3 is 7. And now I look at this and say, man, wouldn't it be really nice if I could have a half here maybe, because, well, what is there? I go 1, do kind of the same thing as 1 plus what times 2 equals 7. Well, wait a second. I don't need a half. And therefore, because a 3 right there would be enough. And now I can again look to see if I have everything reduced. Well, I know I have everything reduced if the number that's in front of one of my compounds is 1, because we don't write ones, then I know for a fact it is the lowest it possibly can. If I have a coefficient in front of all of my compounds, then I do definitely need to double check to make sure that I have the lowest possible. And sometimes you will when that happens. Right, now let's look at the burning of methanol. Well, what are going to be the products of the burning of methanol? Well, just like all of them, it's going to be carbon dioxide and water. All combustion reactions have the outcome of carbon dioxide and water. It's nothing new, it's very repetitive, and that's why I ask that you have that as a memorized product. I know memorization isn't always best for a higher end of learning, but sometimes there are just things that it is a memorization, and once you know it, you know it. We have carbon, we have 1 on each side. Hydrogen, we have 4. Right there with the 4. And then I have 2. And then over on the other side, I have 3 and 3 again. So here we go. But we know that that's going to change things, because to change my hydrogen is going to change my oxygen, and so on and so forth. And let's just kind of see how this works out. To balance out my hydrogen, I need to put a 2 right there, and that will balance out my hydrogen. Now my oxygen are going to be 4, because 2 plus 2 is 4. Now we ask that same question of 1 plus what times 2 equals 4. Now this isn't really nice. It's not a nice easy number, because it's not going to be nice, because 1 plus anything is going to make it an odd number unless what I have here is 1.5. Well, can't have halves. If I put a 1.5 there, I can't do that. It's not lowest number. But what I can do is I can then multiply everything by that, all coefficients by 2, and from there I can say 2, 3, 2. This 2 becomes a 4. And now let's double check ourselves. The 2 there, 2 on the other side. I now have 2 times 4 is 8. 8 on the other side as well for hydrogen. Oxygen, 2 oxygen plus 6. 2 plus 6 is 8. And now I can count up over here. 2 times 2 is 4, plus 4 is 8. And therefore, now I know I have it balanced, but is it the lowest number? Well, if I divide everything, I can see I'm like, ooh, I got a lot of 2s and 4s. Well, if I divide that by 2, I get 1. But if I divide that by 2, I get a half. And I know I can't do that. So this is the lowest common way. And so sometimes we can use these 1/2s or 2.5 or whatever it may be to help us out, as that will make our lives just a little bit easier, as we can see. Now, for the last one here, we have methane. You said a number of times before, this is probably the method most people use to heat their homes, and therefore it's a good reaction to do because it's one that's commonly found. And the byproducts are, or just the products are, is carbon dioxide, no surprise there, and water, and those should be gases. And so we have those as our reactants, our products. We go in and we start seeing, okay, I have carbon, hydrogen, and oxygen. I have 1 carbon on one side. I have 1 carbon on the other side. I have 4 hydrogen, 2 hydrogen on the product side. I have 2 oxygen on the reactant side, and then I have 3 on the product side. And so now I see that my things aren't balanced out again, so I need to go through that whole process again, just like always. And so, keeping my carbons away and leaving them as nice as possible, I'll put a 2 in front of my water, so that will be 4. And then 2 plus 2 is 4 for my oxygen on the product side, putting a 2 in front of the oxygen on the reactant side will give me a total of 4 oxygen on the reactant side, making my reaction balanced as we now have it. That should be the last of the chemical reactions that we're going to look at for this class. For this unit, we'll continue looking at some of the other ones, and we will start adding on some other the quantities part of that next time.